Okay, so one thing that you'll see if we look at number 1 is that we have our unit circle here. If I use this, let me go crop, make this right here, see if that gets any better or worse. Yeah, it gets a lot better. So if that is our picture in number 1, we see that x is cosine. So remember, on the unit circle, cosine of theta is x. So this is an xy pair. It's also a cosine sine pair. So sine of theta is y, and tangent theta is just y over x. So that means that cosine of theta is negative 15 over 17, and y is 8 over 17. That means that tangent is going to be 8 divided by 17, all of that divided by negative 15 over 17. And notice, to do that, we take this one and multiply it by the reciprocal of the second. Those cancel out, get 8 over negative 15. Now, why is that great? Because as soon as we know that, we get some for free. Specifically, we know that over here, we know that cosecant of theta is going to be 17 over 8. We know that secant of theta is going to be, negative 17 over 15. And we know that cotangent of theta is going to be negative 15 over 8. So that was number 1. Let's see. So the other ones that I need over here, so that's 1. Also need 3 and 4. So let's do number 3. So give me just 1 second. Get my picture over here. So if I've got 3, same sort of deal, kablamo. So there's 3. Use the photo. Let me crop that again. So when you're looking here, the main thing to think is that we are looking for cosine is x and sine is y. So if this is my picture, I know sine, cosine, tangent. Well, if cosine is x, and remember we're on the unit circle, r is equal to 1, then this is going to be 24 over 25, and the sine of theta is going to be the y coordinate because we're on the unit circle. So that means that tangent is just going to be negative 7 over 24 because you're going to take that divided by that. But then we get cosecant for free. It's negative 25 over 7. We get secant for free. It's just the reciprocal of cosine. It's 25 over 24. And then cotangent of theta is going to be negative 7 over 24, right? All right, so that's 1, 3. Let's see if we can't see number 4. So 4 up here. Okay, 4, same sort of deal. Taking a picture. Here is 4. Use the photo and then crop it. So we're trying to remember that cosine is x and sine is y. Let's see if I can get it to look a little bit nicer. Any better? Yeah, it's a little bit better. So this is number 4. So sine theta, cosine theta, and tangent theta. So if sine of theta is my y coordinate and my x coordinate is cosine, then this is going to be negative 12 over 13 because sine is y, and this cosine is going to be negative 5 over 13. So tangent is 12 over 5. That means that cosecant is going to be the reciprocal of sine, so negative 13 over 12. Secant is the reciprocal of cosine, so it's negative 13 over 5. And cotangent is going to be 5 over 12. So there's 1, 2, 3, and 4. Let's look at number 6. So for number 6, they say that we have negative 8. So So negative 8 over 17. And we have 15 over 17. So anytime we can, we should be drawing a picture. So I've got a negative x and a positive y, so I'm over here somewhere. So negative 8 over 17 and 15 over 17. And it wants to know if we can find this new point. So if this is my original point, and you tell me to take, for part A, my point and add pi radians, well, if I add pi radians, I'm going to be right over here. And so this point is going to be, it's going to have 8 over 17, the same x coordinate, but then a negative y coordinate, negative 15 over 7, right? If I take, for part B, if I take my original and I go backwards by pi units, that means I'm going to go this way. So I'm going to subtract pi units. Then again, I'm still going to have 8 over 17 and negative 15 over 17. It's going to get me to the same spot. If, for part C, I take my point, but then go in the negative direction with my radians. So instead of going, let's see, give me another color. Instead of going this way, t units, I'm going to go this way, negative t units. So I'm going to end up over here. Negative t units is going to put me down here, right? So almost like 2/3 of the circle. I'm going to be 2/3 of the circle down here. Notice what it's going to do. It's going to give me still a negative 8 over 17, same x coordinate, but different y coordinates. Negative 15 over 17, right? Okay, and then for D is in donut. So for D is in donut, first I make it negative t, and then I go around pi units. So first I make it negative t, which would get me right to where I was, and then I subtract pi units. That's going to put me back over here in the first quadrant. So it's going to give me up here in the first quadrant. Again, if I go negative t, that's this way. Oh, and then I subtract pi units. Okay, it's going to put me right here, yes? So that's going to be both of them positive. It's going to be in the first quadrant. It's going to be 8 over 17 and 15 over 17. So the real idea there is we're seeing that all those have similar x and y coordinates. They're just off by a sign, which is pretty amazing. So if I look at number 11, it's got 3 pi over 2, and it's got, for A, and then it's got, for B, it's got negative 7 pi over 2. It says find the point on the unit circle that corresponds to, yeah, okay. All right, so it says that they open up, P is a point on the unit circle, so they open up 3 pi over 2. It wants to know what are the x and y coordinates on that thing. And so the x and y coordinates on the unit circle, if I open that far, are 0, negative 1. There you go, and that's it, right? And so then if I have negative 7 pi over 2, well, if I go in the negative direction, that means I go this way. That is going to be 6 pi over 2. That's 2 pi. And then I go one more. So that's going to put me right there. So it's still going to have the same sine and cosine. It's going to still have the same x and y coordinates. So that's 11. 14. If you can tell people as they come in to just be a little quiet, I'm almost done. So 14. If you've got 3 pi over 4 and negative 7 pi over 4, notice what you do. 3 pi over 4 is less than 4 pi over 4. Okay. notice what I could do if I've got 3 pi over 4. Do you agree that it's going to have similar x and y coordinates to pi over 4, except it's just in this other quadrant, yes? So it's for pi over 4, this is root 2 over 2, root 2 over 2. So over here, it's going to be negative root 2 over 2 and the square root of 2 over 2. We're going to talk about that relationship here in a little bit in an upcoming lesson. Here, if we go negative 7 pi over 4, well, all the way around to here would be negative 8 pi over 4. So I stop one short, and I've got the square root of 2 over 2 and the square root of 2 over 2. So if I stop short 1 pi over 4, I'm almost all the way around. I'm almost done. 16. So 16 is 7 pi over 4. And B is negative 3 pi over 4. So if I go 7 pi over 4 in a positive direction, I go all the way and I stop right here, short 1 pi over 4. I don't go a full 8 pi's over 4. So it turns out that it's going to have the exact same x coordinate as pi over 4. So it's going to have the exact same x coordinate, and its y coordinate will be negative. Over here, negative 3 pi's over 4. So if I go over here and stop, negative 3 pi over 4 is going to have a very similar x and y to our old buddy pi over 4, yes? It's going to have pi over 4, that's its x and y coordinate. So over here, they're just both going to be negative. So the x coordinate is negative square root of 2 over 2 and the square root of 2 over 2. So we're just really learning how to think about points in other quadrants in terms of the first quadrant, and we'll do more of that as we go along. See you next time.